We left off in the workbook yesterday. You guys are still talking? Okay. We left off in the workbook yesterday with you guys doing 1 and 2. I think us pushing forward and having you do like 3 and 4 is kind of unnecessary at the moment. But we're going to go forward with it and check out the next part of the binomial theorem, which is our introduction to probability. So if two events are, and it's written in bold here, mutually exclusive, that means that they cannot occur at the same time, then you simply add the two probabilities if you want to find out what the probability of both events occurring is going to be. So, now most of these times these probabilities are just written in fraction form. Okay, right? So, I'm just clearing my throat. Okay. All right, so example, really quick. What is the probability of rolling a 2 or a 4 on a 6-sided die? At any point in time, could you roll a single, so all non-sarcastic answers aside, all sarcastic answers aside, if I roll a 6-sided die, one die, right, can I roll a 2 and a 4 at the same time on it? No, right? It's going to come up a 1, a 2, a 3, a 4, a 5, or a 6. So if I'm rolling that 6-sided die, what is the probability of rolling a 2 or a 4? So 2 out of 6, 1/3, correct. So that very easy question, probability of rolling a 2 or a 4. Right? In your notes, it's a little bit more of an expanded question. Well, the probability of a 2 is a 1 out of 6. Probability of a 4 is 1 out of 6. So the probability of a 2 or a 4, because they are mutually exclusive, is 1/6 plus 1/6, which is 2/6, which is 1/3. So there's our probability. That's pretty, yeah, you guys can get that written down. Okay, that's easy stuff. It is, when we know it. But right now we can get something, we can get a binomial experiment. So I'm going to read it straight from your paper here, Sydney. You're good. A binomial experiment is a multi-trial event. It should say event. That should say a multi-trial event where each trial has only two possible outcomes, success or failure. And that's defined by you. It depends on what we're talking about. If the probability of success is P and the probability of failure is defined as Q, which is 1 minus P, the probability of a binomial experiment, and you will recognize that exact same formula and choose R. We'll get to that in just a second.
Wait, that means Q is failure then?
Q is failure, right? And it's really super easy, right? So if the probability of success is, let's say, 75%, what's the probability of failure? 25. Right, okay, so that's why Q is defined as 1 minus P, right? So 75%, so that's 0.75. 1 minus 0.75 is 0.25. We can get there on our own pretty easily. So, that being said, we have a binomial experiment, the probability of an event occurring. The probability of an event occurring is, and let me make sure I use all those same letters, N choose R, P to the R, Q to the N minus R. Okay, good, I used all the right letters. All right, so this is very simple. So this is, where does the binomial theorem come up in? It comes up in probability, which is something that very wealthy paid people called actuaries use on a daily basis. They're the ones who calculate, like, hey, if Martina were to go get a driver's license in the United States, what should we charge her for insurance purposes given all this information? Her age, her gender, her GPA, right? Her income level of her parents. All these things tell us what are the chances, the odds of her getting in a car accident, therefore how much should we charge her to make sure that we try to make a profit, right? So example, you play 4 rounds of a card game with your friends. You guys following me? Uh-huh. You play 4 rounds of a card game with your friends. You have a 1 in 4 chance of winning each game. What is the probability of you winning exactly 3 games?
So we just have to plug it in.
Right. So the probability, no, because your probability of winning is, right, 1 in 4, right? So what is your probability of winning 3 games? So out of how many games are that you're playing? Out of 4 games, how many do you want to win? 3. What's your probability of winning? 1/4. How many do you want to win?
3.
Okay, what's your probability of failing?
75. 3 out of 4.
3 out of 4.
Yeah.
And how many of those need to happen? 1.
Okay.
Well, because that's 4 minus 3,
Wait, what? Oh, yeah.
which is going to be 1. Okay? So, and Stephanie, you are just having a big old conversation with Leticia while I'm teaching, and we need to stop that.
Why gotta
I have
figure out on the
2
video
fluences. I
like
can
that?
listen and I can.
Ah.
Oh, Sammy, don't touch it.
Tim.
Jaden, you dropped it.
Okay.
Oh, you did.
Sydney, here for Yvonne.
Alright. You had one-handed interception. You're all cool.
Ooh, everybody got one over there? Okay. Everybody good? Oh, Gansky? Okay. You got your own, right? Okay. All right.
0. Okay, but I mean,
Okay, guys.
I had the best catch of the year, though.
4, choose 3. Let's make sure you remember how to do that. 4, second, 8, 3, enter. And you should get 4.
Wait, what happened? Say that again. I was off. 4 seconds, 8.
Mm-hmm. Then equals.
Okay, yeah. So NCR is what we're gonna say.
What was that? Yes, we're going to do a times after that. So this would end up being 4. 1/4 to the 3rd power, so that's 1/64, yeah?
Yes.
3/4 to the 1st power, that's 3/4. Okay?
I think I'm getting it from yesterday. I was at the doctor, so you can't be mad.
I'm never mad. Your guys' education is your call.
You say that all the time.
But I was at the doctor.
So,
Matt.
No one said
what's your point?
I
Okay.
was at the doctor, so don't
Is
be
that what he
mad.
says to you, Tim? I'm not mad. I'm not mad, man. Yelling at you.
Good, you can tell him, Tim. You don't got to look at him as if like,
See? This is
my,
why I think.
He's sometimes mad.
am I ever mad at my students, Tim?
Do I count?
You don't count.
No.
Yep. Okay. My kids get my anger. You guys don't. Okay. Are we good, though?
Take your anger out on other kids.
We good? All right. So, guys, here, make sure you reduce if you can. 4 and 4 can cancel.
Okay.
3/64. Please divide. What is 3 divided by 64?
I got you.
2?
21.
Oh, so it's 0.21.
No. It's 0.04675. Yeah.
No, 3 divided by 64.
0.04685.
Ooh. Okay. Okay. So, guys, if you're playing four rounds of this card game with your friends and you've got a 25% chance of winning, the chance of you winning 3 of them is only 4%.
Wait, that doesn't sound
That
right.
kind of makes sense, though.
It really does.
When,
I feel like I feel like it's a little too low.
It's not.
I feel like it should be around like 8%. No.
So, now,
It's like it.
so we have to decipher now what we talk about when I say, what is the probability of you winning at most 3 games? What does that mean, at most?
you can win
At least
up to
you could-
Up to, which means I could win
1, 2, or 3.
close. I could win
3 or 4.
1, 2, or 3, or 0. I could win no games.
What is the probability?
Okay.
Because it's at most, right?
Correct.
No. So now we're gonna have to
Okay.
grade that.
So now it's going to be the same thing, but you put it instead of 3 or 4.
Okay. All right, so at most 3 games. Now, these are mutually exclusive events. Could I win 0 games and I could also win 1 game? No. If I've won 1 game, I've won 1 game. I haven't won 0. If I've won 0 games, I haven't won 1 game.
We're all in 1 game.
No, draws aren't happening. So what we're going to do is we're going to do the probability. So it's going to be the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. We're going to add these. So we're going to have to do the same thing as this. Now, we already have this answer, at least. But we're going to have to do 0, 1, 2, and 3. So that's going to be 4 choose 0. 1/4, I'll have won 0 of those. 3/4, 4. Make sure we understand that. So out of the 4 games, I won 0. I had a 25% chance of winning. That didn't happen. I had a 75% chance of losing. That has to happen 4 times. It will be. Yeah. I mean, I could set that up ahead of time. But it would just be an equal sign on the far left. Plus, yes, Amanda. And subtracting that from 100. You could. Let's check to see that works, because this is the last example, and I'm just going to cut you loose for the rest of the period. Okay? So that's a great observation, Amanda. We're going to do that in a second.
I did it right. Plus 4.68,
Hey.
right?
76 games
Yeah.
out of 87.
Okay. So I'd rather you guys just retype me a new one instead of just writing all over that one. Huh? Oh, you're not adding? I thought you said.
Another one in. Just 2.
Yeah, I got a question.
Yes.
Why did the 3 change to 2? Like, why is the exponent of the last one?
So out of 4 games, win 0. So 25% chance to win none of them. So you're good now? So out of 4 games, I'd win 1, lose 3. Out of 4 games, win 2, lose 2.
So the first one was...
Hold on, some people are still asking questions here. What's up? Sydney?
The exponent of the 4, how drops to 3, 2? Is that
This exponent?
no, the exponent's of my
Because I'm changing how many games I'm winning. Out of 4 games, I win 0. This is my winning one.
Oh, and that's your losing one.
And this is my losing one. Yeah.
Then if the 1/4 is going to have how many you win and 3/4 is going to have how many you lose.
Correct.
And since you played 4 games and lost 0, the first is 0.
Right. Yes.
Yeah.
We already solved that one. Correct. So here, we've got 3 to the 4th, which is 27. No, 81. Over 256. Here we have 4 times. These cancel. That's nice. But we'll. And here we're going to have 27 over 64. Six times 1/16 times 9/16. All right. I'm going to give a 30-second pause and see if you guys have any questions on where my numbers come from. Adrian? This is a 16, yeah. Whose music is going?
Pretty sure it's coming out of the backpack that says music.
Mine?
No way.
Oh, yeah. This dude.
He was
Okay, I changed my ringtone like last night. So like, I liked it at the time, but I forgot I changed it, so I didn't expect it to be that one.
Okay.
See, that's why I was jamming.
Because this is just 1. That's just 1. And so 3 to the 4th is 81. 4 to the 4th is 256. No? What do you mean? Right. 3 to the 4th. 3 times 3 times 3 times 3 is 81. 4 to the 4th is 256. And I'm waiting right now just for those types of questions, so you're fine, Samuel. Any other questions about how I got each of those items? Alexa.
Such a rapid move. I'm a rap about math.
The last one?
Like what you just said.
This one? Or what? Oh, the last thing I said?
Yeah.
4 choose 0 is 1. 1/4 to the 0 is 1, because anything to the 0th power is 1. 3 to the 4th power is 81. 4 to the 4th power is 256.
Oh, okay, so that'd be like the same thing on the second one. That 3 to the 4th power.
3 cubed is 27. 4 cubed is 64.
Okay.
Yes?
Where'd the 6 come from? Because the 4 choose for. Oh, yeah, you do it on the calculator. Okay, sorry. I was like, wait a minute. Where's that?
Yeah, 4 choose 2 calculator, that's a 6. Yeah. What's up? Hold on a minute. Oh, did I not give you one?
Oh, wow. Oh, wow.
Yes. What? Why'd you break it?
Oh, one of the buttons might be pushed in, like in.
That's it.
Because mine was doing it.
So, yeah, so we take a look at it at an angle. I don't see anything stuck. Maybe I shouldn't toss them. Oh, I just turned it off and on again, and it works now.
Oh,
I just turned it off and
I
on.
see that. I kept pressing that.
Okay. All right, guys. So calculator, decimal it up. 81 divided by 256. Take it out to the.
It's 0.316.
Give me one more decimal. Huh?
4.
4. Okay.
Plus
27 divided by 64.
0.4218.
Okay. 6 times. So we have 54, 256.
Did the 16s cancel out?
No. 16 times 16 is 256. Is it not working again, Josiah?
Did even working now.
Oh, no, yeah. I simplified it.
Oh, right now your equal button's stuck down. You see that?
Come on, Josiah, get the program.
Okay. All right. So,
Do we add them all together?
yeah, what's this one?
0.210993.
That's good enough. Okay. So add those together.
We add them all together, right?
Yeah. Guys.
Shut up.
0 point what?
9959.
You have a 90. So if you've got a 25% chance of winning one game, if you play 4 games, there's a 99.6% chance you're going to win one of them or more.
I feel
Okay.
like that's a little too high. No, come on, 99% chance you're gonna. What if you just suck at the game? Come on, you gotta live.
Okay, Tim.
It's not a counting skill.
The point in 7046.
They got a different number. They
Oh,
got.
I didn't add one.
Oh. Okay.
But like, if I do a test, I'm over here with, oh, this doesn't look right. There's no way it's coming 99.6%.
No. So it's a 99.6% chance that you're going to win.
At least the game.
No, actually, I'm lying. It's not at least a game. I'm sorry. That's a probability that you will win 0, 1, 2, or 3 games.
Oh, well, that makes sense.
Yeah, 0.
But you know that
Winning all 4 games, you gotta be pro.
So Sydney, if we want to take out the 0, what's the probability that you will win 1, 2, or 3? We would just remove this one, right? And then that would take us down to about a 68% chance that we're going to win in 1, 2, or 3 games. Okay? Now, to do Amanda's method, okay? To do Amanda's. Amanda said, well, couldn't we just subtract from 100%? Couldn't we just subtract from 100% the probability of winning all four? Because this is really saying we don't win all four. We either win 0, 1, 2, or 3 games. We are not going to win all four. So Amanda said,
Wait, I got a question.
Yeah.
So the chance of winning 0 games is
31%.
And the chance of winning 1 game is 42, and it drops like that.
Yeah.
Got you.
And it just goes 4%.
Yeah.
Well, because it's hard.
That's winning 3 games.
The odds are not in your favor. That's winning 3 games. The odds are not. You remember, 25. You have a 75% chance of losing every time the games go out. So for you to win 3, it's hard.
Well, this Vegas be doing this.
This is absolutely Vegas. You're talking about Vegas odds. Those people get paid lots of money to design those games. All right. So we could do 1 minus the probability of winning all 4. So that would be 1 minus.
Can we write on the back?
Sure. 1 minus 4, choose 4. Now how many? That's saying we win all 4 and we lose 0. 4 choose 4 is 1 times 1 over 256 times 1. So that's 1 minus 1 over 256. I should probably put these all in parentheses instead. Let me do that. Because, okay, so to Amanda's logic,
Oh.
we're saying we asked for the probability of winning 0, 1, 2, or 3. Well, the only thing we didn't take into consideration was winning all 4. So she said, wouldn't it just be 100% chance minus the probability of winning all 4?
Oh, so
This is
another way.
another way of calculating the same thing. Right.
Okay.
So 1 divided by 256, 0.00. That's fine. Okay, so what's 1 minus that?
0.9961.
There we go.
Close.
It's close. And if we didn't round each one of these at some point, they'd be identical.
Yeah, I got 0.995.
Sydney. Right? As long as we could think about it. Sydney?
Why did 3/4 go to 1?
Why did what? Oh, anything to the zeroth power. Yeah.
Wait.
Yeah.
So this one, you win if you win all 4.
Right.
That's sure. That's your percentage of winning all 4 games.
And then you
Yeah.
subtract it from 100.
But then this one is the probability of winning at most 3.
Right. This is the probability of winning all 4 right here. This is your probability of winning at most 3, which means you could do 0, 1, 2, or 3.
That's way easier.
It is if you can wrap your mind around it. So Alexa's having problems just that concept connecting.
So you got 0.3% to
So
win
that
all
0.0039 is your percent to win 4 games.
Correct.
And that 0.9961 is your percent to win
Up
most
to
3.
at most 3. Yes.
Oh, so you just subtract the total from 100 to
Correct.
get the 3.
Yes.
So then this one's actually more accurate, isn't it though?
Because the fact this is more accurate, yes, because of the fact that you don't have rounding error in 4 different numbers. But they're both acceptable. Okay, you guys have your homework. You have the rest of the period to work on it.
May I have a
Wait, what about the workbook questions?
Oh, the work. Do you want to do the workbook questions? Let's do the workbook questions
Sammy, why'd you say something?
because it helps us. It helps us.
I want to know it.
Yeah,
I'm just saying, like,
I agree.
Sammy, good thinking.
That's on me.
I see as it helps. Oh, I do have another one.
Yeah.
are you posting the video from yesterday?
Yeah, I'll be posting all 3. Okay. All right, guys. And you get 6-1. Yeah.
Yeah, I just added the fractions.
Right. Okay. So, Samuel. Okay. No, you're good, Samuel. Of the new cars in a car dealer's lot, 1 and 6 are white. 4 cars were sold. So 4 is our N. We're choosing up to 4 cars, right? What is the probability that 3 were white? So white is a success. Don't read into that, please, children. Okay?
Wait, a success? Yeah, that's our. Because we have a success and failure rate.
Yeah, so when we're doing which ones are successes, we're considering white to be a success. And I said don't read into that. We're not
So
being
1 out of 6
we're not being
right?
racial here. Yeah, 1/6 is our success. So out of 4, we want 3. Are we okay with that?
Yeah.
4, choose 3. White car is 1 out of 6. We want 3 of those to be white. And then what's not white? 5 out of 6. And then we calculate that.
Wait. What? Oh, because there's a 5 or 6 chance of it.
Right. If there's a 1 in 6 chance of getting a white car, then there's a 5 in 6 chance of getting anything other than white.
Feel it. Wait, I got you.
We have 5 and 6 chance of getting 1 white.
Of non-white.
Oh,
So it'd be 4,
1 in 6 chance of getting.
and then 3.
so then the 3 is the cars that could be white.
Yep.
What's 6 cubed?
216.
Times 6.
I don't. I recalculate it.
You're just humongous.
So then we multiply all 3 of them?
Yeah.
Can you do them on here?
You can do a fraction on here, guys. If you want, if you wanted to, you could. This button right here next to the 1, it says A, B/C. You could push 1, then that button, then 6, and that's 1/6. So. Yes. Yeah, as long you can use it. That's any of mine or your own, as long as it's not graphing. Yeah. What do we get, guys?
5 over 108. I got 5 over 108.
It's just an unfair advantage, and there are certain questions that we'll get to where it can calculate things that I want you to still do by hand.
I don't know
Eh.
how to use my graph. I got 5 over 108. It's like, oh, look.
5 over 108. Because, and did you do the 4, 2, 3 in front of it?
Yeah.
Okay, which is approximately what percentage? 5 divided by 108.
0.04629.
I'm just going with Alexa's numbers. If you guys want to refute it, then tell me.
Because there's the fractions on here.
5 over what? Okay. You guys can't ask me why what went wrong when I'm just taking your guys' word for it. Yeah. Oh. Well, 4 choose 3 is 4 times 1 over 216 times 5 over 6. You got to tell me more than wait what.
Yeah, I did it wrong. I put 216 twice.
You got it? Okay. So 5 over 648?
What? No, 5 over 324.
324?
Yeah.
Okay. Which is?
0.01543. 1.5.
Stephanie? I know, and I just sometimes don't feel like re-explaining since your head was turned towards Leticia so much. but I will.
Okay.
What you got though? No, you can. You can. I don't mind answering. Go ahead. What?
I don't understand what you say.
Which one? What part? You good here? Here.
No,
Right here.
no, the 5 over 124.
So we just reduced because 4, 216 and 6, I can divide that by 4, and I'll get 54. 54 times 6 is 324.
Well, you divided the 4 by 2 6.
Yeah, this is reduces.
I didn't know that reduces.
I thought you were supposed to multiply.
I just did it on here. I don't know.
On one part, calculate
Yeah.
4 over 1 times.
But you could get the same answer. You still did.
Yeah. All right. At least 2, which means you can have
1 or 2. Or 0.
or 0. Don't forget that 0. So do 0, 1, or 2. Or you could do 1 minus 3, 4. I mean, if you were really splitting hairs, you already did 3 anyways. So do the 0. 1, 2.
Wouldn't it be 5 over 6 4?
Oh, 4. Yeah. Can't draw. And that should be a 3. I don't know why I didn't. And then oh no, we want 2. Shoot. Not 3. That's 3. That didn't help. Sorry. Now, what was your question, Jaden? Okay. Where are you getting confused, Sydney? So 4, 324. 6. I mean, whatever we get. Calculator, slow me down until we get to that point. Then I want them.
I don't know how I got decimals.
Well, once your denominator gets too big and for the calculator, I think once your denominator gets to 4 digits, it's just going to do it in decimals. Your calculator will not keep a 4-digit denominator.
Oh.
Is it a different formula than yesterday?
Nope. Yes.
Where's the exponent button on the calculator?
Y to the x.
Where's that?
Above the plus sign, I think.
I was looking at the seconds.
Yes.
So wait, can you explain though? So like it's like you have a 1 in 6 chance to get the 2 exponent. What does that mean? I forgot. Like you know how it says 4 chooses 0.
Yes.
1 over 6 and then 0 as an exponent. It meant something, but I'm trying to figure out what it meant. I forgot.
So you want at least 2. Oh shoot. You guys. Me saying that makes Stephanie give up.
Because we only wanted 2.
Okay. We wanted at least 2, which means we want 2 or 3.
Not at most 2.
Not at most 2.
That's why I was confused.
Well, you should have spoke up.
Oh, I just thought I was dumb.
All right. So what we're gonna do right here to make our lives easy Haha. Because if it was at least 2, we would have done 3 and 4 only, or 2, 3, and 4. We'd,
erased it.
when I said you guys, you erased that fast?
He was trying to be a step ahead of the game.
But I written it as least as most. I decided to erase it.
Sucks for you. Okay. I was trying to help out for people to not have to erase a bunch.
People like me who are lazy and get
Okay.
benefited
I
from
can't
them.
put 1296 in the calculator.
No, you can't. So you're going to have to do 625 divided by 1296 plus. I was. Thank you, Samuel. Thank you. So this is saying out of 4 cars bought, I'm going to choose none of them to be white. So that means no white, 4 non-white. 1 white, 3 non-white. 2 white, 2 non-white.
So, as you get, if you have a 1 in 6 chance to get, when you have a 1 in 6 chance to get 1 white card,
You'd have a.
Exponent, the left exponent, how I took it was a success, and the success of what it's going to be.
Our success is getting a white car.
In a white car, so the
Right.
first one is a success, which is you got 0 success. And
No successes, 4 non-successes.
like, PS4 chooses 0.
Right. What percentage does this end up being?
I'm doing it.
43. 53.
53%?
some type of number.
94.
What? No.
No, like I got 0.94.
Yeah, me too. No.
Oh, no.
0.981.
0.947.
Now I'm confused.
0.947.
9171.
You're getting like 4 different answers. That's what I got.
I got 5.30987663.
I divided them all first and then added them.
Oh, yeah, yeah, right.
Oh, I was like, wait a minute.
Okay, I went one bigger than that.
That's fine.
What I always wanted to do, I wanted like those old like feather pencils, like dip them in ink and start writing names.
Okay. Huh? No. Yeah, we're talking in December. Okay. So sorry about that. It was at most. Sydney, you were correct that we should have done 2, 3, 4 instead because it said at least. Does that make sense to everybody if I just read it wrong? Yeah, at most versus at least. The next 2, are there really any difference? The next 2 questions, 7 and 8.
Would that mean that at least no? Never mind. I'm not gonna ask.
Yeah. Okay.
I think 7 and 8 are the same.
7 and 8, they're all the same, guys. They're all the same. So this is just practicing the use of that formula. Samuel, do you feel all right if we want to skip the remainder of the workbook questions? Do you want to do? Yeah, you're good. Okay. Does anybody want to do any? If you want to do more of them, we can. Otherwise, I'll cut you loose to start doing your homework questions.
We've done 2 at most, and none of the at least ones.
Yeah.
You want to do one at least? You want to do number 8?
'Cause
Let's do number 8.
Wait, I haven't covered all that down yet. Alright, thank you.
Or we could do the 1 minus that Amanda talked about. Or the 1, whatever, we'll see. In a lottery, each ticket buyer has a 1 in 10, so our success is 1/10, which means our failure is 9/10. That'd be great. Well, but buying 10 doesn't guarantee a win. Okay. If Chip buys 10 tickets, what is the probability he will win at least 1 prize? So he buys 10 tickets. This is what you said, Sydney. What is the probability he gets at least 1? Okay. So out of 10, at least 1 means he wants. All right, so let's break this down. So at least 1, so we want the probability of 1 plus the probability of 2 plus all the way to the probability of 10. We want at least one. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, correct? I need a yes out of that before I, okay? Is everybody good with that? Yvonne, you good with that? Which is the same thing as 1 minus the probability of what's not in here, 0. It'll be a 1 minus the probability of 0, because I don't want to win no tickets. Yeah. I don't. So 1 minus, 10 choose 0, 1/10 to the 0, 9/10 to the 10th. Where am I losing you?
So. I thought that's n minus k at the top.
It just switched those. It's multiplication anyway, so 5 times 8 is the same thing as 8 times 5. So which one goes first doesn't matter.
Can I show it here?
Now I know exactly what you're talking about. This is my n, and this is my n. Sorry, this is my n minus k,
Oh yeah.
and this is my n.
Your k?
My k. Yeah.
Ah, you just switch.
Yeah.
And you don't.
But it's the same thing. It doesn't matter.
So you just leave the 10 there because 10 minus 0 is 10.
Correct.
Okay.
Where's the exponent of y over x?
I don't know. I don't want to do 9 to the 10th and 10 to the 10th. What does this end up being? 1 minus 0.00. What is it? No, that's 9 times 9 times 9 times 9 times.
No, 9 over 10.
Oh, 9/10. Oh, yes, yes. So that's
0.9.
point. That's 0.1 to the 10th. So
Wait,
1, 2, 3.
very good probability.
This is 9.
Yeah. Yeah.
99.999999999999999.
Yeah. Well, it's actually a terminating, but still.
There's 10 zeros or 9 zeros? 9 zeros or 10 zeros?
10 zeros.
What? Well, technically, 9 zeros after the decimal.
Oh, it should be 9 zeros. There should be 9.
9 after the decimal?
Yeah.
But there's already 9 after decimal.
You already put 9 after the decimal.
Oh, I did? I thought I counted right. 1, 2, 3. Okay. No, okay. I don't. It's unnecessary to go that far.
Why don't you just put the repeating sign?
It's not repeating because it does terminate right there. It doesn't keep going. It doesn't
Nine,
have one.
that's it.
So it's 99%.
Yeah. If you buy tickets, it's not guaranteed. There's a 99.9. Josiah, something's bothering you, and you keep on trying to say it.
Buying 10 tickets.
What?
How did you get 0.006 from 9, 10 to the power 10, 10 to the power 10? No, that's
Your argument? Oh, 0.9.
yes.
Top, top, top. Oh, then it's going to change everything.
0.34867844.
That was 0.1. My mistake. Okay. I asked you a while ago and you guys didn't answer. Please be quicker about that then, because you had called me on doing it way earlier, and I said, "What is the number?" And you give me a number, guys. I'm not standing here with a calculator. I'm expecting work out of you guys.
0.34867844.
That's what this is.
Yeah.
0.3486.
7844.
All right. 1 minus that.
That's roughly 0.6513.
All right. 60. So Sydney, if you had a 10% chance of winning from a lotto ticket and you bought 10 of them, you'd actually still only have a 65% chance of winning.
Still buy 10 lots.
How'd
Oh,
you get
you can buy 20.
0.348?
Bro, I was a millionaire.
So what they did, Alexa, what they did was he went ahead and just reduced this. 9/10 is 0.9, so he did 0.9 to the 10th.
Mr. Bates, if you were a millionaire, would you spend $10,000 on
Oh, somebody's out. When Tim gets back, huh?
If you were a millionaire, would you spend $10,000 on you had $8 million?
No. I wouldn't buy lottery tickets if I had $1 million.
Why not?
Because $1 million isn't more than enough for me to figure out how to live on for the rest of my life.
Sydney.
I don't know about that.
Actually, that is like
Never mind.
a very, very decent amount of money.
Yeah.
Think about it. Like, if you take your yearly salary,
Yeah.
I'm just
You
gonna.
have why is it a 9 out of 10?
It's go big or go home.
Because if success is 1 out of 10, failure is 9 out. If I have a 10% chance of winning, I have a 90% chance of losing.
Homeless, I'm gonna be Richard and Elon
You have a 1
Musk.
out of 10 chance of winning.
That's what it said, right?
You have a 9
There's
out of
no
10 chance of losing.
Yeah.
I'm betting all my life savings and my $1 million
Make sense?
on
Yeah, no,
one.
Okay.
So you're gonna do what Chris McCandless?
Yes.
Just donate all your money to
It's either I'm gonna be a hobo or I'm gonna be Richard and Elon Musk. There's no.
Okay. Why would I terminate anybody? Who am I terminating?
If I have